This time on the bench is something from the bench. You may recall last time I blew my power supply up testing an amplifier. Well, it's time to fix it. It went wrong when I had 1, 2, 3 dual rail power supplies all on the same amplifier trying to power up multiple stages. It didn't like it. The power supply in question is Thurlby Thandar, or TTI as they're now known, CPX400A. Like a lot of the older test instruments, it's got quite a small sort of face profile, but they're quite deep. You need a deep bench for this equipment. Not much to see at the rear, just where you plug the power in. And here's the problem. This side works, or it appears to work, set current limit. This side's just completely unresponsive. It's difficult to say what's wrong. It's saying constant voltage. It's not in current limit, so quite often when these things blow up you get short circuits, and that's why there's no voltage. But this one, a bit different. Just check these voltages. Put that meter on there. Put some test leads in. So we're getting about the right value. Maybe this meter's a little bit out, but you know, maybe I can adjust that as well. I'm more worried about this one. Presumably nothing's coming out. Oh, now that's interesting. We are getting output. So if I turn these all the way up, I get 59.5 volts there. You turn this up as well. Yes, it's working. Okay, the power supply works. It's the measurement that's gone wrong. Could it be the local and remote sense? No, it doesn't appear to be. I hadn't checked that before and I'm surprised. I thought it was worse than that. Well, it could be easier to fix than I think. Well, I'll just now turn it off. Just need to whip the lid off this. Usually find accessing test equipment's a lot easier. Just a few screws. And we're in. You can clearly see a left and a right hand channel. They look identical. The bits in the middle I think are just common power supplies, I'd guess. I haven't actually checked. And the front panel has got the display, and I reckon this is where the measurements are done. This is where the fault is. A few more screws. It looks exactly the same left and right here, so this is not too bad to work on. I'll pull these plugs off. Disconnect these outputs as well. Well, at first glance I don't see anything burnt or broken. This connector here is obviously a load of power supplies on here. I need to check these. There's a +5, -5, +15. Yeah, there's all sorts going on. But I'm looking to see if there's any burnt little surface mount resistors. I would imagine around here this is to do with the measurement or the analog side of it. And here we've got a PIC chip. There's a PIC 16F something. No doubt that's going to be driving the display, so I think that's working. I hope it's working because that's programmed, and if that's knackered I'm in trouble. I can't see anything obvious, so I'll probably need to make some measurements. It looks like this board actually can unscrew and actually tip it up, so yeah, it might be a good idea, so I can actually reassemble the thing and get to it. But it still won't lift out, it's still trapped by these cables. I'm going to have to undo these, I think. I think because the fault is it's not showing even the set voltages or anything, it probably doesn't need to be connected. Just going to pop the power switch out because the lead's a bit short. Just connect it here. And just put it in the on position. Or is that the on position? We'll find out. Now we might be able to get at this thing. Just connect these plugs. Power supply for each side. I should be able to spread this out now and measure the top, which is good, but I just need to space this off the chassis, don't it shorting. This wooden block in there. Let's see how it behaves with half the wires missing. So for the voltage set points and the current set points, this is working fine. That's good news. Obviously this side isn't still working. So I can trace the fault in this situation. I printed the board layout out of the service manual to show me what connections do what on this front board. It's important to check the power supplies. So we've got a 0 volts, -5, +15, +5 and a 5V analogue and a 0 volts analogue. I don't know what GA is. Luckily, same on this side which works, so I can compare them. So the third pin along is the 0 volts, and then we'll go along here. So we've got -5, +15, well +16 in this case, +5. Between these two we've got 5 volts. And this last one, GA, measures 15. -5, +16, +5, +5 again, and over at the end, +15. This connector here, okay, 4.2. So we haven't got a missing supply rails, we have to dig more into the measurement circuit. This is the schematic for the front panel. There's a lot going on. We can pick up the voltage measurement from the external sense terminals which are here. They find their way to these points, which appear over here. We can easily trace this through to just simple resistors and stuff, and go straight to this chip here on pins 15 and 16. And this chip is an ADS1241, which is an analog to digital converter. And this converter scales its measurements between the voltage applied between terminals 9 and 10, the reference, which will be 2.45 volts. We should see if that's present. You might need to pick it up on another component, say C102. C102 is this ceramic cap just next to this pot. It's a bit fiddly to get at. -2.5, I'm just the wrong way around with the leads, so yeah, it's not quite right, but it's present. So the reference circuit's working, so we need to pick up on an actual measurement. So these from the sense terms are no good looking at because they're disconnected now. So I need to find something that's going to be there all the time. Maybe this one, the voltage set point, which is measured across C133. So I'll probably compare both channels, so I'm going to set the knobs both in the central position. Make them as close as possible. So on the working circuit, that's going to be this one here, so we see 33. We've got 0.65 volts, okay. And on the dead channel, that's this one here. 0.62 volts, that's good. Well, it's looking like the A to D converter's not working for some reason. Now the chip may be faulty, but we should check everything else because they're probably not cheap. I presume this PIC chip is working because it's actually driving the display. Even though it says 0, it's still driving it. The communication between these two chips is through a serial interface. I've got 3 lines here to check. So it's actually going to be easier to measure it on the PIC chip, which is using the corner pins. So pins 13, 14, 15 and 16. A bit easier to reach. So we're going to need the scope on to see the data. Put the scope ground on pin 2, the programming port, which is the ground. Nice and convenient on here. I'm going to start on pin 13, which is the chip select on this PIC chip. And there we have it. Well, that's working. Now pin 14 is the serial clock. That's looking fine to me. Perfect. Serial data input into the A to D converter is actually pin 16, just there. And that's working okay. Pin 15 is the serial data from the A to D converter. Nothing there. Not a sausage. Very crude signal injectors putting your finger on. Look at that. Serial data. Is it too soon to condemn that chip yet? I'm going to check the supplies and the clock signal, and then I think it is condemned. I'll check the power supply, that's pin 1. Yeah, 5 volts, that's good. And pin 3 is the clock. Looks like that chip is faulty, and I don't know why that would have got damaged by the amplifier incident. It's very deep in the circuit, it shouldn't have happened. I think it's a coincidence, or just rotten luck. Before I order a replacement chip, I'm going to swap the two over, see if I can transfer the fault from one to the other, then I know for sure. I'm going to use hot air to desolder it. Might take a little while to warm the board up. You need some patience doing this. That's coming. It's off. Just going to wipe the pads with a soldering iron just to drag off any sort of excess, although there shouldn't be a lot of excess. That's preparation. I've put a bit of solder flux on there. We put some leady solder on there with the lower melting points, which makes resoldering that a little bit easier. Now that's a good chip taken off. Going to swap it over with the bad one, hopefully. Hot air again, more patience. Looking for signs for the solder melting. It's not always obvious. Now we've got it. Okay. Bad chips off. Bit of flux on there. Like before, give it a wipe. Hot air back on. I'll look out for these start to melt. They're looking shiny. I think that's it. Now back to the other side. See all that solder turning shiny? That's a good sign. Oh. And that's got that one too. Now you can plug it all back in. Hopefully it says 0 on this display now when this one works. Perfect. I've never been so happy to see this side gone wrong. I've tried the world's biggest marketplace, not so confident about these sources. I'm going with DigiKey because they've got a good reputation and they've got the stock, that's the main thing. Although the price does go up somewhat when you include the shipping and the VAT. It's not taking long to turn up, which is good news. This tap doesn't work very well though. Knife it is. It's a rather large bag for a single chip. And that's the part we've been waiting for. So it's hot air again to get it off. For those of you wondering, it's 320 degrees air coming out of here. Perfectly hot enough. So I'm going to put a bit more solder flux on. Just got to get the chip out of the packet. More hot air again. I think that's okay. Just give that a little test then, like we did before. Right, moment of truth. Beautiful. Beautiful, that's what I like. Working. Current halfway up on both. Similar numbers. Yes. I think I need to partially put it back together so I can still get at the adjustment pots, because you can't calibrate it like this. Get the ball to sit back where it should be. Line these plastic standoffs in the right place. Got to put all these connections back now. Plugs are simple enough to work out. If I can get them the right way around. This black lead here and the red lead went on there. Be helpfully labelled up. Just want to make sure that these leads here don't touch against that diode. Although it probably doesn't matter, are they connected to the same place maybe? No, I don't know. I'm not going to risk it anyway. Right, they've all been mechanically swayed into providing a bit of clearance, which is how they were originally. The caps aren't bent over now. I'm trying to attach the longest leads first, but it's difficult to know which they are. It's all pretty tight. Trying to get these ring terminals back over these posts. That feels tight as well. Very short cables. We ought to put this switch back in first. Finally, these two. I'm going to hook the meter back up to this so I can see how far out it is. Especially now I've changed the chips, it might be a bit different. Yeah, you've got a bit of a discrepancy on the two. 50 millivolts. I mean, it's not far out, but you know, it is apart. We've got 38.43 here. Ah, 38.43 there. That's pretty good. On the measurements agree all the way to the top of the range. See if they catch up with each other. 16.55. Oh, this is perfect. Nothing wrong with the measurements on this channel. Apart from that, that's interesting. Okay. This does need a bit of adjustment. What's this one do? 30.61. 30.69. Okay. I need to adjust it all. Fortunately, the service manual tells you exactly what to do. There's only 1 or 2 pages of it, so I'm not sure I'm going to do all of it, mind you. Well, the first part of the calibration is to turn the output on. We need to adjust the voltage down to say 0.02 volts. It'll take a while to get there, mind you. Oh, look at that. Then we should turn the output off. Then we need to adjust a pot to bring this to say the same thing, 0.02. This is VR116 down here. Let's put a screwdriver tip in there. Okay. Next step is to turn the output on and measure the output voltage when you crank the knobs all the way up. Make sure we're getting 61.7 odd volts. Okay. Output on, all the way up. And it's supposed to be 61.7 odd volts, and it's not. And that's VR105 I need to get that with. I don't need to adjust that, these are pretty closely matched, happy with that. When I turn it off, yeah, running a bit high. Need to adjust that. That'll be VR110 to change that. So close. Do the same to this side. Point 0.02 volts we need. Now we turn it off, and it should say the same, 0.02. So that's VR16. Oh, it's a little bit melted here. How did that happen? That pot's not budging, looks like I've melted it. Damn it. I'll have to take the board out and fix that. It's getting a bit easier to take apart now. Done it a few times. Yes, this is entirely my fault, because right next to the chip that we changed is this pot, and look what a mess it is. The pot I've melted is this one here, 47k we need. Luckily, happen to have one in the parts drawer. Annoying it's a through hole pot, so I've had to take the whole board out to get at it. That's so annoying. Oh well. It unsolders as conventional. I don't think any of these pins are connected to ground, that's good news. There we go. One dead pot out. Put the new one in. It's a little bit taller, but hopefully if the legs line up, we should be good. You'd never know, apart from it doesn't match the others. Here we go again. So we can get it to sit flat like we did before. That's better. Right, now where was I? Calibration. Right, okay, I've set the output voltage to 0.02 volts, so when I turn the output off it should measure the same. Right, that needs adjusting. Hopefully it will adjust now. Right, VR16. This one works. Perfect. Now to turn it on, and crank it all the way up. But they don't agree with each other, that's the first thing, and it's not 61.75 volts, so VR5 it is. Okay. Blimey, that's good. Switch the output off. I just sat with VR10. So that voltage calibration's done. Next thing to look at is the current calibration, and the first step is to check that it can read 10 milliamps properly. It tells you to set the current all the way up, oh we're 20 amps, and put a 1k resistor in. It should be 10 milliamps if you turn it on. There we go. No drama there. And the next step is to set the current limit to minimum and check that we've got 3 milliamps. Current to minimum, 10 volts, put the leads in. For the load I'm using the 1k resistor again between these two clock leads. Connect that in there. Turn it on. It says it's in current limit, that's encouraging. But I've connected it in the wrong socket, it should go in there. Okay, we got half a milliamp. That's out of spec. VR8 just hiding here. I think that's as good as I'm getting it. It's a very twitchy control, that is. Right, the next part requires me to increase the load to 18 amps. Oh. Can't do that with a resistor. Something a bit more substantial. Well, I'm not sure these leads are up for 20 amps, but we'll do. See how we get on. Okay, current up to maximum it says. Well, at 10 amps it's pretty close. It does sound supposed to take it to 18, I'm a little nervous. $17.99, we'll see how I can get on with that. VR7. $17.98. That'll do. I've already checked the low end current on this channel before off camera and it's fine, so I'm just going to go with the 18 amps on this one. So we'll go for the 10 amp, or go the 10 volt settings. Current up, turn it on. $17.98. The next part is Powerflex calibration. Now I'm going to set it to 7.3 amps load and adjust it to the unreg light lights up. Oh, okay. The voltage up to maximum. I set this to 7.3 amps, so 7. There's a cursor. I'll make it 7.35. Bit of headroom there. And turn it on. Oh, hang on a minute. This electronic load's only good for 350 watts, and we're going to put what? 60 times 7.3 volts, 438 watts we're going to stick through it. Rather than blow more test equipment up, I'm just going to verify that the power supply displays are actually accurate. Other than that, that's good enough for me. I brought the multimeter back to play to measure the voltage at the terminals and the electronic load I'm going to use for current calibration. Turn the load on. 3 amps on this reading here. Yeah. I'm liking this so far. Go to 4 amps. Yeah, it's all looking good. We'll go 2 amps. Yeah. Just checking the lower ranges, I don't want to get caught out. 5 volts, something you'd use a lot. 4.999, yeah, happy. 1 amp. 2 amps. Yeah, this is fine. 7. 10 amps, 9.99, yeah, I'm more than happy with this. Let's turn that one off, swap to this channel. Turn that on. 10 volts, set 10 amps on here. Yeah, 9.99, 9.98, yeah, close enough for me. Turn the current down a little bit. 3 amps, let's crank the voltage up. 33.48. Yeah, pretty close. No complaints here from me. Let's check the very low voltages. $5 volts would be typical of what you're using. 4.99. Let's increase the current. So we've got 4, 5, 6, 7, 8, 9, 10 amps. Yeah. So we'll check the current limit. So change the mode to resistance mode on this. Constant resistance low, 6 ohms. That'll work. going to set that to say 2 amps. Something like that. Okay, we'll go back on. I'll increase the voltage now. We should see it going to current limit. There we are. The same on this channel now, 2 amp current limit into 6 ohms. It's good so far. Let's turn the voltage up. There we go. Constant current, 2 amps. I really don't think this needs any more adjustment. I'm happy with it. I put a lid on. These wires are rather stiff to get into place, I have to say. Let's plug that in here. And the meter back in. Need to provide an air gap for the vents under here, so I'll stick these wooden blocks under. Put 4 under there, just to lift this up. Everything back in its place and working, that's how I like it. Catch you next time.